Okay, so here's a second part of an electrochem test that I found online on the Solera website. So just going through some of these questions. The first one I saw, so this is more the second half of the electrochem unit, focusing on voltaic cells and electrolytic cells. So this first one, we have a cell and they're showing the electron movement. So we know based on voltaic cells and electrolytic cells, electrons always move from the anode. So this one would be the anode to the cathode. So I know that because they're showing the electron movement. So I know cadmium is my anode, which would mean at my cathode, the reaction to do with mercury would be the reaction that's happening there, since we do have an inert electrode. So when it's saying the standard potential for the cell is 1.25, and then asking what the reduction half cell is for cadmium, we want to use the information that we definitely know and not just look at cadmium in the data booklet. And I don't think we could find it anyway, so we probably have to do it this way. And your cell potential, E of the cell, is always the potential at the cathode minus the anode. So when we're filling this in, we know that the whole cell is 1.25. The cathode is the information with mercury. So I just did a quick screenshot on page 9 of our data booklet, and that is positive 0.85. And then we're going to subtract our anode and solve. So they are implying the negative here. So we can just put this into our calculator and move the 0.85 to the other side. So let's do that. And we get, sorry, my dog's barking here, 0.4 will equal the negative anode. So divide both sides by a -1, and we'll know that that negative should be there, and the anode's half cell is 0.40. So the voltage at the anode, or the cell potential for the anode, is 0.40. Moving on to this next one, we have another voltaic cell. And within the cell, if we're taking a look what's happening, again, it is giving us the electron movement. It's showing that it's going from here to here. So we would know that the anode would be electrode 2 and the cathode would be electrode 1. So when we're going through it, we've just found out the first part. So we would have 2 for the anode, 6 for the cathode. Asking about the electrolyte. So the electrolyte is what you see in solution. So it would be number 5. Oh, sorry, that should have been went there. And the last part, a product of the reaction. So product would be what's coming out. And so we're seeing, even though I drew over it, this arrow with water being formed. So that would be number 4. So here our answer would 2, 6, 5, 4. Moving on to this next one. Looking at our half cell and then being able to describe it. So it tells us we have an electrochemical cell, which is also called a voltaic cell. And then asking which of the following equations represents the reduction half reaction taking place during normal operation. So now we'll just have to read this over a little bit. So we have number 1, it's telling us that it is a platinum strip. So platinum would be this one here, and that is an electrode that is inert and it wouldn't be in our data booklet. So nickel would be number 2 here. And we have our insulated copper wire. That's how our electrons are going to flow. And then we have a mixture with potassium chromate and HCl. And then we have also a solution of nickel. This solution would be where our solution is, and then that porous barrier. Now asking which equation represents the reduction half reaction. Reduction happens at the cathode. So with everything reacting, we have to figure out what is at the cathode. So I would go through this and just take a look at what's reacting. So again, we have platinum there, but it's inert, so we don't have to consider it. You have nickel solid. You have, what else do we have? We have the copper wire. But we can write that down, but it shouldn't be part of our reaction because that's just where our electrons are traveling. You have potassium permanganate, so that means you have that's chromate, not permanganate. K positive and Cr2O7. You also have HCl, which is a strong acid, so H ions and Cl ions. And I'm just missing water. We also have water present because we're in solution. So going through this, if it is reduction, you are looking for your strongest oxidizing agent. And if you take a look at your data booklet, your strongest oxidizing agent would be when chromate and hydrogen are together. So that half reaction that you're going to look for is D. Now, moving on to this last question here. This one is, again, another voltaic cell, and we see what's happening within, and it tells us that the piece of information that lets us figure out what's happening is that the anions in the cell move from the hydrogen half cell into the salt bridge and migrate towards the X electrode. So that means if the salt bridge is moving towards the X electrode, it's because the X would be breaking up. X would be turning into the X2 positive and 2 electrons. Those electrons would leave into the wire to go over to the cathode, and X2 positive will be added to the solution. So to neutralize that solution, the negative anions from the salt bridge will come and travel over. So with that, now we do know that X is our anode, and the side over here with the inner electrode would be your cathode. So then if we're taking a look and reading the question, as the cell operates, electrons flow from, they're going to flow from X over to the inert. Now the other part here is asking about pH. So the first part, just to see what's, we can narrow it down to either A or B, because we know they're going from X to the inner electrode. And then it's asking about the pH of the cell. So on the side that has hydrogen, that would have the pH, as the electrons come on over, they are going to pull the hydrogen's ions out of solution, and they will end up forming hydrogen gas. So if we are decreasing the concentration of the hydrogen ions, that means you're decreasing the acidity and your pH would increase. So the pH of the hydrogen half cell is going to get higher, because for your pH scale, as you go 1, 2, 3, and you keep going, the higher your number is, the less acidic you are. So that's why the answer here is A. So we have one more. So with this last one, taking a look, we have our cell as described here, and then asking about the reduction half cell. So with this, you just want to go through, and again, reduction happens at the cathode, and reduction means you're looking for your strongest OA. So you would go through this and see that you have zinc as an RA, zinc 2 positive would be an OA, copper 2 positive would be an OA, and copper solid would be an RA. Then you would take a look at your data booklet, and you would see that copper 2 positive is your strongest OA, and that reduction half reaction would show copper gaining those electrons and making copper solid. Okay, so as always, I hope you found this helpful. If you did, please subscribe, and if there's any other question I can ever do for you, just let me know in the comments. Thanks for watching.